The topic for today's video, understanding the fundamentals of subtractive synthesis in under 10 minutes. And since time is of the essence, let's get right into it. The fundamentals of subtractive synthesis go hand in hand with the fundamentals of synthesis, despite the namesake of the synthesizer. And we're going to go through a couple examples here very quickly. So here we have the tall LX. We have a sound generator, in this case an oscillator, being shaped further by a filter. Here we have diva, and we're going to see the exact same thing. We have some kind of a sound source, oscillators here, being shaped by a filter. Now here comes a different example. We have the phase 4, which is technically considered a phase modulation, frequency modulation synthesizer. Yet again, what we are actually doing, despite doing some phase modulation and frequency modulation, none of that is changing over time. The thing that's changing over time is the filter. So really, this is a patch that's utilizing subtractive techniques more so than it's using phase modulation or frequency modulation. Same thing is true with an instrument like Serum. You might be thinking, oh, well, that's a wavetable synthesizer. It can be a wavetable synthesizer. It can also be a subtractive synthesizer, which is the way that we're utilizing it here. We have, again, sound generators going into some kind of a filter. And really the point of this video isn't to teach you subtractive synthesis just inside of a box, but to help you dissect patches that you might pull up in modern synthesizers, something like Serum, where we can take the basic subtractive patch and turn it into something that's a little more hybridized. We're now going to incorporate some wavetable goodness and create a hybrid of the two. So we now are utilizing some wavetable methods along with subtractive methods. Here we have the most basic of subtractive synthesizers. But as you can hear, it's capable of some pretty big and wild sounds. But before we get up to that, let's go ahead and bring this thing all the way back to the bare bones, the initialized state, as close to default or 0 as you're going to get. Let's hit a note. So the first thing we have to go to, the first section we want to find, are the sound generators. In this case, we have 2 oscillators, and we are only listening to oscillator 1 right now. It is set to be a sawtooth wave, and then our pitch is being determined by this octave control. Luckily, this instrument is just going to be in tune straight out of the gate, and we can just change the octave there. If we want to bring in some of our second oscillator, we'll just bring this up here to like 50-50. We can offset the pitch up an octave, and then if we want some fine tune, almost like micro pitch adjustments, we'll control this sense knob here. And we can hear how those two guys play off of each other. One thing worth mentioning here in our waveforms is that we can try some different shapes. Right now we have 2 sawtooth waves, but we could also try a square on one of them, or a triangle on one of them, or a pulse wave where we have control over the pulse width using this pulse width modulation control. So as we bring that up, we can kind of hear that we're thinning out the sound. So lots of different timbres to get started with. And when you're doing subtractive synthesis, you typically try to build up your block of sound first, whether that's a really rich sound or a really dull sound. So I'll just experiment quickly. Down here, it looks like we might even have a noise that we could bring in if we were so inclined, but we're just going to stick to our sawtooth wave. We're not going to touch on syncing. We're not going to touch on what low does, because honestly, that's kind of beyond the realm of our basic fundamentals for subtractive synthesis. So here we have our sound. And what really makes this subtractive is having a filter and utilizing the filter. So right now, I really wouldn't call this a subtractive patch. This is just a sound. So what's going to make this subtractive is to take some of those upper harmonics and start to filter them out. Now Now with this instrument, it's very simple. It's just a basic low pass filter with a few different steepness modes. Here we have 12, 18, and 24. And as you hear with each of those, we start to cut off a little bit more of those higher frequencies. So let's go right in the middle here. If we want to add a boost at the cutoff position, we'll add resonance. Almost gives it like a nasally sort of characteristic. Right now we have a very static sound. I hit the key, it comes on, I let go of the key, it shuts off. The only kind of variation in this sound is being caused by the slight detune between the two oscillators. So let's take this further. Let's make this sound more dynamic. And to do that, we'll take advantage of modulators. In synthesizers, the two most common modulators you're going to see are envelopes and LFOs. Okay, so envelopes relate to what happens on like a key press, for example. So our second envelope here controls the amplitude level. And the first thing we have is attack. That's how long it takes to go from 0 up to the loudest value. So let's put this up to about 60 and we're going to hear the sound fade in. Release controls what happens after you let go of the key or you release it. And because this is on 0, as soon as I release the key, no matter where I'm at in the envelope, it just cuts off. So let's kind of match that. Let's bring that up to about 60, 55, whatever. And I let go of the key. And again, I let go of the key. We can hear how it fades out. Now we have one additional little envelope here. These two are related. We have the decay and the sustain. So how this works is once I bring this sustain value down, let's say that I put this at 50. Let's see if we hear any difference. Oh, okay, interesting. So we can hear there's almost like a clicking that occurs. So after the attack, it's wanting to go to the sustain, but it's wanting to do that immediately because our decay is set to 0. So what will happen is as I bring up a decay time, it's going to be the signal coming up to full volume and then decaying down to the sustain level based on the decay time. So let's put our decay time right to 50. We'll hear the sound come up and then pretty quickly drop down. And let's make it more natural. So let's bring this up a little bit. We can also use envelopes to control things like the filter, or we could use an envelope to control something like the pitch. We'll do the most classic example, which is an envelope on the filter. So I can set up which envelope I want controlling the filter. So let's say I also want envelope 2 to control the filter. I just have to set an amount. So until I bring this amount up, we're not going to hear anything. But now I'm going to bring it up and it's going to do exactly the same thing. So it's now going to control the cutoff. It's going to go up. It's going to come back down. And when I release, it's going to get back to that starting point. So let's take a listen. We can also apply keyboard tracking to the filter cutoff. So right now, listen to the highest frequency that you're hearing. If I bring keyboard tracking up, what that's going to do is the higher I play on the keyboard, the more this cutoff is going to be willing to open up. So I'm going to bring this all the way up. And you can hear how much brighter it becomes as that envelope reaches its peak value. We also have an LFO, which is more of a cyclical repetition. So we can put the LFO on, let's say, the pitch, okay? And it's going to now control both oscillator 1 and 2, which would be great. I want it to be consistent. And I'm going to bring this LFO on. So we can hear it wobbling. And then we have control of that down here. So we have different shapes for the LFO. Now, what might be useful is that we sync this to our tempo. So our tempo is at 118. So I can now sync this to the tempo, and let's say it's going to go in quarter notes. So we can sync that in with our track that's playing in the background. And that's really all there is to subtractive synthesis. Those are the fundamentals. So when you bring in a synthesizer and you pull up a preset, you see there's a lot of filtering going on. Envelopes are impacting the filter. Envelopes are impacting the oscillators. LFOs are involved. You know you've got something subtractive on your hands, and you should be able to modify that preset to help it fit into your productions. Thanks for watching. Take care.